The dependency issue that we saw in the last movie was the result of this polyselect modifier. Instead of using polyselect, let's get smart, and we can do this non-destructively using a volume select modifier. So I'll select the polyselect modifier and remove it from the stack. And that's done by clicking on the trash can icon. Remove modifier from the stack. Boom, it's deleted. Now, ironically, when we did that, we deleted everything because this delete mesh modifier up here is operating on the entire sphere. Let's just disable that for a second. And now we want to add a volume select modifier. If we have the sphere selected, then the volume select will be placed directly above the current modifier. And that's the rule. The modifier you add will always be stacked above the currently selected one. We'll go into the modifier list, and we want to find volume select. And it's here under selection modifiers, vol select. Okay, activate that. And we get a box, and that is currently selecting everything. If we turn our delete mesh back on again, our geometry disappears. All right, let's manipulate this box to define the volume or the region in which we want this delete mesh modifier to operate. Go into the volume select modifier and open up the little arrow. And we have sub-object types here. The one that we want is gizmo. That's the manipulator for this volume select modifier. Activate gizmo sub-object mode and use the move tool and move the gizmo up. Now, as you do it, you won't see anything at first. And that's because the stack selection level here is set to object. So it's selecting the entire object. But let's switch this over to face. And now as we move our volume select gizmo up and down, we can delete everything that's enclosed within that volume. And we can also do things like scale it. That's kind of helpful. Maybe we want this to be a little bit larger just in case this gets moved over a little bit. We don't want to see that sort of thing happen. All right, I'll undo that with Control Z. I can scale that gizmo a little bit, so use the scale tool. Choose select and uniform scale. And this is definitely a situation in which scaling is not only safe but desirable. We're not scaling an object. We're scaling a gizmo within a modifier that's having an effect on the object. I know it's a bit confusing because we're using the same tool here, the same button, but we're not actually scaling the object. We're doing an effect. All right, so scale that up by clicking directly in the center, right in the middle there. All right, go back to the move tool and maybe position that. And again, that's a non-destructive deletion. And now the magic comes in. If we go back down to our sphere, we do not get the topology dependence warning. And that's because volume select is not really caring about which exact vertices and faces we've selected. It's not explicitly selecting things. It's implicitly selecting anything that just happens to be inside that volume. And now we can increase our segments. We can crank that up to whatever we want. And you'll see it jumps around a little bit depending upon where the boundary between these edges and the volume select modifier are. So it's going to have a little bit of wiggle room in there. But we still have a lot of power here to non-destructively and procedurally model our object. All right, so let's say I want this to be a value of like 72. Very cool. And this is not an explicit editable object. In other words, it's not an object in which we have predetermined the position of every point on it. It's not been baked out to an editable mesh or editable poly. This is an object that is completely procedural and is built up from very simple instructions. When I save this scene, I'm not saving the positions of every vertex on the object. Rather, instead, I'm saving these simple instructions. Make a sphere that has 72 segments. Select anything that's inside this volume and delete it. And every time we open this scene, this object gets reconstructed from those simple, sort of formulaic instructions. In this case, it's a simple object with simple instructions, and it's going to be a very small file size, and it's going to load very quickly. But if you had a very complicated object that was, let's say, very heavy, had a high level of detail, and or had many modifiers doing many complicated things, then you would notice that although your file size may be small, when you open the scene, it takes a very long time to load. And that's because 3ds Max has to calculate that entire equation or formula of all the instructions you've given. So there is a benefit to procedural modeling, which is it's non-destructive and that you can make changes. There's also a downside, which is that once you get to a certain level of complexity, it actually kind of bogs down your system. All right, so that's how we can non-destructively delete or make any other operation upon a selection based on volume.